Hello everyone, welcome to my channel. So today I am going to teach you what is signals and how the signals are handled in Linux. So signals are a very important topic in process control in Unix. So let's understand what is signals. So signal is an asynchronous event which is delivered to the process. So asynchronous event means the event can occur at any time. So it is an event, it is a small message that is been sent usually to the process. So either to the termination of the process or for the creation of the process. So signal is an asynchronous event. So there are various type of signals. Let's see that what this is. So in Unix there are system 5. There are 19 different signals. So signals related to termination of the process. Either it is signals are related to the terminal interaction for the user mode or signals related to the induced exception, etc. So basically there are 19 signals in the system 5. So and whenever the signals come, your execution from uh, the kernel moves from user mode to kernel mode and the kernel handles the signals. So as I already told, it is an asynchronous event. It can occur at any time. So it is a message given to the process what to do. So whenever the signal comes, so based upon the signal, the action will be taken by the kernel. So here are the few examples of the signals. So if I tell what is SIG, so whenever means I press a Ctrl C, so a signal called as SIGINT uh, signal is been sent to the process. So default action for this signal, that is SIGINT, that is signal from the keyboard interrupt. Keyboard interrupt signal. It is basically a keyboard interrupt signal. So whenever the keyboard interrupt signal arrives, so the basic default action for that is to terminate the process. So same thing happens with the signal quit signal. So SIGQuit is the name of the signal. So that is whenever you press the control backslash, this type of signal is be generated. That is SIGQuit. So basic default action is also to terminate the process, but it terminates by creating a core image. Like core images, you can say that it is a snapshot of what the process is currently doing. So a file name with a name called as core is been created in the current directory and it will be dumped. Like what the process was currently doing, it is dumped and then the process will be terminated. So that is what happens when you press the control backslash. So whenever you press the control backslash, this signal called SIGQuit signal will be sent to the process. So whenever you are terminating the process using the kill system call or kill command, kill and the command name. So at the background, a signal called SIG kill will be sending to the process. So indicating or signaling to the process to terminate the process. So, or if you already know, I get a pipe where in the pipe you need the two process. One is reader and the writer process. If there is a writer process and there are no other reader process, then also a message will be sent or a signal will be sent that is called as SIG pipe, where usual action is terminate the process. Another example is death of child signal, what we call, and it is called as SIG CHLD signal. So this signal informs the death of child to the parent. So if one of the child becomes zombie by executing the exit system call or coming out of the its execution, so the process becomes dead. That is, process becomes zombie. So when the process becomes zombie, the child informs its parent as it becomes dead. So that signal name is SIGCHLD. That is indicating that I am dead. That is death of child. So when the parent receives this signal, that is SIGCHLD, so the parent process understands that one of its child process is been dead. So in this way, the signals are being sent between the process and the actions are taken. So whenever the signal comes, this image is for interrupt handling. But whenever the signal comes also, your execution mode will be going from user mode to kernel mode, and a stack has been pushed. Like here in this case, whenever the system call comes, a stack has been pushed. Similarly, when the signal comes, a stack has been pushed here. That is called as contest layer. And in this stack, actually the signal will be handled. Like signal, if I am handling a signal, means a default action is being performed, it will be handled here. Or if I'm handling a signal by user defined functions, then that function call, that virtual address of the signal catcher function will be called here, and it will be executed. So in the coming slide, we will see whenever the signal comes, we can do the three things, or the kernel does the three things. Either it can perform the default action, it can ignore the signal, or it can handle the signal. User defined functions can be executed whenever the signal comes. So where it is executed, in this context layer. Okay, whenever a stack has been pushed, and the signal catching function, either it will be called, or default action, whatever the task is there, that virtual address will be called and the execution will be done. So once the execution has been done, the kernel mode means a stack will be popped, again it will be back into the user mode. So this is what kernel does at the background. So let's see how can we handle the signals. Already I told, whenever the signal comes, three things has to be done. So but before that, what is the system syntax for the signal handling? So the system call for signal handling is signal. So first parameter that it takes the signal function is the signal name number or signal name. And the example of signal name already I have shown in the previous slide. And then the signal handling function. So it can be user defined, it can be default, or it can be ignored. We'll see that. So just remember this, whenever the signal comes, three things I have to do. Either the process can ignore or discard the signal, either it can execute the signal handler function, or it carry out the default action. Okay, so you can ignore or discard the signal. So for this, not possible with SIG kill signal or SIG stop signal. So for these two signals, so you cannot ignore it. But for rest of all of the signals, you can ignore or discard the signal. Execute the signal handling function. As I told, whenever the signal comes, I can perform the signal handling function. Instead of performing the default action, I can call the signal handling function. So this is one thing that can be done, or perform the carryout action. That is the three things. So this is the three choices that the process can do whenever the signal comes. So value for ignoring the signal is SIG underscore IGN, and value for the default action is SIG underscore DF. So let's understand this with a practical example. So just minimize this PPT. I will open my command prompt. I have already installed WSL here. Okay. First of all, we'll see how the signals are coming. So for instance, I don't write simple things, right? I just want to use the Ctrl C signal. Let me handle the Ctrl C signal. That is the keyboard interrupt signal. So just I am writing an infinite loop. So main purpose of writing this infinity loop is so that I can press the Ctrl C and come out. So just I have written nothing. I have written an infinite loop for loop. So let me compile this. CC signal.c. Let me run this. And since it is an infinite loop, and you can see here my prompt is means blinking. So it's not ready, it is in the infinite loop. So obviously when it is in infinite loop, my default action usually many of the students, or you might have been also pressing Ctrl C and Ctrl Z. When you press Ctrl C, Z, that SIG stop signal will be sent, and when you press the Ctrl C, that is keyboard interrupt signal will be sent. That is SIG INT signal. So just I'll press the Ctrl C and show you. So whenever I press the Ctrl C, now this is what happened. So whenever I press the Ctrl C, so a signal called a SIGINT signal. So this signal, as you can see, whenever the Ctrl C and SIGINT signal came, and the default action for this was to terminate the process. This is what it is done. Right. So once again, I show you. So I am pressing Ctrl C, and default action is to terminate. So let's handle this. So this was the default action. Let me see how to handle this signal. Let me create another file. So all the signals are being defined in the header file called signal.h. So you have to use the signal.h. Let me take an user defined signal called signal proc, something like that. So to handle the signal, so the system call is signal, so which I already informed you signal. Then the signal name which you want to handle it. So signal name is SI. I want to handle the Ctrl C, that is the keyboard interrupt signal. So I'll write SIGINT. Then whenever this signal comes, so signal, it has to move to the signal handling function, that is SIGPORC. So I've done this. So let me again define the infinite loop so that I can press the Ctrl C. Then here I will write about the definition of this this function, that is SIGPOR. So I'll just write a printf statement here. Ctrl plus C is being pressed and the signal SIGINT is being successfully handled. All right. So nothing more in this program. I just, so whenever this signal comes SIGINT, it will move to the my user defined function, that is SIGPROC function, and in this function I have written nothing, that is Ctrl C is being pressed and the signal SIGINT is being successful. Now what happens is, so if you are hanged, then you will press the Ctrl C. Whenever you Ctrl C, you are pressing, this signal will be arriving, that is SIGINT. And whenever this signal is coming, by default action, it means I am handling the signal. So it will move to this function called SIGPORC, and here a printf statement will be executed. So this is what happens. So let me compile. Okay. Now, yes, I have shown you earlier the default action for Ctrl C is to terminate the process. Now, but now in this program, that is SIG1.c, I handle the signal. That is, whenever I press in the Ctrl C, it is going to my function called SIGPORC, and in the SIGPORC, I have written that printf statement. So you can see here. So whenever the Ctrl C has been pressed, so you can see here. So whenever I press the Ctrl C, a message has been sent, like it is Ctrl C has been pressed and the signal SIG has been successfully handled. Yes, there is no stoppage here. So whenever I press the Ctrl C, it will be handled. All right. So whenever you are pressing the Ctrl C. So as you can see, whenever pressing the Ctrl C, a signal called SIGINT will be sent to the process and it will be handled. Means a message called Ctrl C is being pressed. So there is no stoppage. This is infinite loop. So whenever I press Ctrl C, so the message will be continuously come. So how can I come out? I can press Ctrl Z again, or I can press Ctrl \. So I have pressed the control /. So this is also one of the signal. So for this signal, a core image will be created. Already I told you what is core image. Core image is nothing but a snapshot of what the process is currently doing. So a file name with a name called as core will be created, and it will be dumped the whatever the process was doing. So that is done using the control quit. So this is the signal that is being set. So if you can see here, so a SIGQUIT signal will be sent, that is creating a core image. Default action is once again the terminate the process, but it is creating a core image as well as coming out of it. So now if you want to perform, if you want to ignore the signal, so already I told in this PPT what is the ignore. So for ignoring a signal, you have to write a value called SIG_IGN. Now I am ignoring a signal. I am not handling a signal. I am ignoring a signal. Ignore in the sense, so the kernel or the process behaves like the signal has never been arrived to the process. So the process behaves like nobody means I am ignoring a signal. Which signal I am ignoring? SIGINT. I can ignore as many signals, but this is the one of the signals which I am ignoring. So whenever you are pressing the Ctrl C, SIGINT signal will be coming, and whenever this SIGINT signal is coming, so it is ignoring a signal. Means it behaves like nobody have pressed the Ctrl C. It behaves normally, and the normally for this program is to stay in the infinite loop, and it will be staying in the infinite loop. So that is what happens. Right? So whenever I press Ctrl C, you can see at the bottom. Or let me clear this and once again show you. Yes. So now it is there in the infinite loop. I am pressing Ctrl C and nothing is happening. Neither the default action is being performed, neither it has been handled. So that is, it is staying, it is stayed in the infinite loop. So that is what ignoring. So it behaves like nobody has pressed the Ctrl C. So that is what it is, the ignoring the signal. So I can ignore the signal. Again, if you want to handle the signal, you have to take the value as SIG. Default action is to come out. That is to terminate the process. It can come out of this. So let me press Ctrl Z. Let me show you. Yes. So here, default everyone already I showed in the beginning what is the default. Even though if you want to handle it or if you want to perform the default action, you can write DFL is the value for that. Yeah. Yeah. Now it is there in infinite loop. Now when I press Ctrl C, now it will be terminating the process and it will be coming out of this. So this is the default action which I shown you at the beginning of my lecture. So this is what it is happening. So this is all about the signal handling. Yes. So just remember whenever the signal comes, I can do the three things. I can ignore or discard the signal, execute the signal handling function, or I can do the default action. This is the normal algorithm for signal handling. So all of the algorithm name is P signal. Input is none and output is none. So whatever I explain is there in this. That is, whenever the signal comes, signal number will be taken from the process table. If it is the signal is to ignore it, just it will return. If signal specified to handle the signal, then the virtual address of the signal catcher function will be done. That is a stack from, as I told, one context layer will be pushed, and the signal catcher function will be called there. So that address will be copied there, and it will be returned. If the signal type is, sorry, So signal type is to dump the core image, then it will create a file name called as core in the current directory and it will go. So basically it is a simple thing. So if it is ignoring, then it will return it. So if you wants to create a dump image, then a file with the name as core image will be created. A stack will be pushed and a single handler function will be called in that, and signal and catcher function will be executed. This is the algorithm, or this is the background thing what the kernel is doing. So this is all about the signal handling. The signal handling is a very important function, or what we call as an important topic in process control. Many times it has been asked in the exam, and students feel it is very difficult, but it's very very interesting and very simple. I guess you understood what is signal. Hope for the same videos in the coming lectures. I hope you like this lecture. So if you like it, please click and click the subscribe button. Thank you.